All right, for this next part, I'm going to focus on solving, all right, these exponential or logarithmic equations. So when I see an exponential equation like 23, I'm first figuring out, can I rewrite 9 and 1 over 27 with the same base? And I can. 3 to the second power is going to be the same as 9, and 3 to the negative third power is 1/27. So now I'm going to do 3 to the 2x power equals 3 to the negative third power. Make sure you get this step on the final, because if you don't, I'm going to take off points. So 2x has to equal -3, so x equals -3/2. Now, for a logarithmic equation where I have one log on one side, I'm going to rewrite this using a base of 10. So 10 to the third power equals this argument. 10 to the third power is 1,000. I'm going to add 200 to get 1,200. So dividing by 4 gives me 300. Don't forget to check any of these logarithmic equations. So 4 times 300 minus 200 equals 3. You're making sure you don't have any negative arguments, which that's going to be the log of 1,000 equals 3, which is correct. All right, next one. I have two natural logs on the left side of the equation connected by addition. So I'm going to go ahead and multiply x times x minus 1 equals the natural log of 12. So if I go ahead and now I have each of these logs on both sides, I can set the arguments equal to each other. So x times x minus 1 equals 12. I'm going to go ahead and distribute to get x squared minus x equals 12. Setting it equal to 0. I have my two factors, x minus 4, x plus 3. So x equals 4 or x equals -3. Don't forget to check both of these. The natural log of 4 plus the natural log of 4 minus 1 equals the natural log of 12. This is okay because none of my arguments would be a negative, so this one will work. But when I check -3, immediately when I plug in -3 for the first argument, I get negatives actually in both of them. But just need one to be negative, and that's not okay. So I cross that out. Okay, this one, I cannot rewrite 21 using a base of 4 or a base of 2. So I'm going to go ahead and take the log base 4 of 21 equals 2x, right? Basically rewriting this exponential equation as a logarithmic equation. So to get x by itself, I divide by 2. So log base 4 of 21 over 2 equals x. Okay, again, similar to one we did a few problems ago, I'm going to combine these logs, but this time, since it's subtraction, I'm going to write 3x over x minus 1. And then now I'm going to drop the logs and just write 3x over x minus 1 equals 6. Move that x minus 1 over with multiplication to get 6x minus 6. And so I get 3x equals positive 6. So x equals 2. Don't forget to check. Log base 3 of 3 times 2 minus log base 3 of 2 minus 1 equals log base 3 of 6. 3 times 2 is 6, so that works out. 2 minus 1 is 1, that's okay. So this is just fine. All right, next one. Combining these logs with multiplication is going to give me the natural log of 4x minus 6 equals 4. This one I'm going to rewrite using a base of e. So e to the fourth power equals 4x minus 6. So e to the fourth power plus 6 equals 4x. So x equals e to the fourth power plus 6 over 4. Again, plugging back in, you get the natural log of 2 times e to the fourth power plus 6 over 4 minus 3 equals 4. So when I do this, I have e to the fourth power plus 6 over 2. All right, and e to the fourth power is a positive, plus 6 is a positive, divided by 2 is still positive. So the whole thing is has to be bigger than 3, which it will be because e is 2.7183 to the fourth power will be over 16, and then plus 16 is 22 divided by 2. So it'll be over 11 for sure. So we're good. This will work. All right, let's do 3 more. So this one I have the logs are the same on each side. So I'm going to go ahead and drop the logs and set the arguments equal. So I have 4x equals 8, x equals 2. Check it. So I have, that's going to be log base 8 of 9 equals log base 8 of 9. Both are positive. That works. Okay, for this one, I'm going to basically isolate first this base of 2 by moving that minus 8 over first to get 20. Then divide by 5, and you get 4. And now I can rewrite that 4 as 2 squared, and then set the exponents equal. So I get 3x equals 6, or x equals 2. Don't need to check this one, not a logarithmic equation. All right, last one. I'm going to rewrite all of these with bases of 4. So 4 cubed for 64, 4 squared for 16, and 4 to the negative first power. So I'm going to have 4 cubed times 4 to the negative 6x power equals 4 to the 6x minus 4 power. And then I'm going to add to get 3 plus negative 6x. Don't forget, you can't drop until you have one base on each side. So now I have negative 6x plus 3 equals 6x minus 4. So that's going to be 12x equals 7. So x equals 7/12. All right, guys, I think that is it here for my solving. Make sure you come back for the next part where I do some graphing and look at word problems.